Sup, everybody? It's Tuesday, the 4th of April, I believe. 4th of May. 4th of May. Whoa, let's get rid of that. There we go. Yeah, Tuesday, the 4th of May. This is iGCSE Acid-Base Theory, Lesson 1. Let's crack on. I'm reading everyone's on the chat. I love Jack's RIP me. Right. I've suddenly realized I didn't include. Let's see if I can grab my learning object. No, don't want to do that. Oh, no. I've ruined it. Grab my learning objectives. Lots of knowledge today. Lots of knowledge. I need to reopen my YouTube window. I closed it by accident and then pop out the chat. Pop out the chat. May the 4th be with you. Ian, well done. Loving that. I'm loving it. Right, share screen. Haven't done this in a while. Let's crack on, guys. Hide. Oh, I need to switch my camera over to my clip cam. Oh, no. Can't. Got no clip cam. Hang on a sec. Hang on a tickeroni. Let's try that again. There it is. Boom. Can you see me? Yeah. Woo! Name the film, folks. Name the film. Flux capacitor. That's what makes time travel possible. Right. Okay. So let's crack on. Let's see who can give me the, so year 10, give me the film first. Go all the way down to the bottom, add page. So this is acid base. Acids and bases. Acids and bases, lesson 1. And then go paste, here we go. I'll convert my laptop into tablet mode. Turn on my little fan, keep it cool. There we go. There's today's lesson, folks. So 3 learning objectives today, guys. 3 learning objectives. Learning objective number 1. So the last time that you guys really saw acid-base theory, you actually see bits and pieces of it as you go through your GCSE chemistry. But the last time you really saw this topic was probably year 7 or 8. We tend to cover acid. No, we tend to in year 7 call it acids and alkalis. Can I just point out, I hate that. It's not really the correct term. I don't really know why we do it. I don't, but lots of teachers do. The reason being is, I don't know whether it's the AA, the play on the words of acid A and alkali A, maybe, don't know. But the real name of the topic is acids and bases. So, and as I said, the last time you saw this was in year 7 or 8, which is a long time ago. So the first thing that we need to do here, guys, is go through what you learned in year 7, which isn't really very much. It's not really a huge amount that you learn in year 7. You learn about 5 facts, which we'll go through today. You pick up indicators, you pick up neutralization, you pick up acid plus wait, how was I using my private account? You pick up, yeah, as I said, neutralization. You pick up different indicators. You pick up the basic acid plus alkali gives you salt and water. Can I just point out, I hate it. You don't really know the difference between a base. You pick up some properties on acids and bases. So the first thing I'm going to do is recap what you did in Key Stage 3. Whether or not that be in year 7 or 8, doesn't matter. Next thing we're going to do is I'm going to give you your required indicators for GCSE. So GCSE requires you to know these indicators and when you use them. There aren't many, which is great. And then the next one is your acid-base reactions, which you picked up from me when you came in year 10 to me, guys. The very first lesson probably about lesson 1 or maybe 2 or 3, you pick up the acid-base reaction rules. and they're really handy. They're actually super important for you to know those. And we can also do some naming of salts today. So let's crack on. So first thing, key stage 3. Let's run through year 7. Yeah, year 7, acids and bases. Don't know why I capitalized that. Don't know. Acids and base, acid and base. Okay, so in year 7, the first thing you got told is that you can sorry, I'm trying to make little things in my tower disappear. The first thing we did, bullet point number 1, is that you got told that there are 2 families, which is fine. I'm happy to do this. So we realized that there are acids. Number 1, acids. Now this is a family of chemicals. We can categorize things in chemistry in many ways, but one of the ones that you pick up very early is acids and alkalis. Now you can categorize these. And so you learn that acids have distinct properties. So let's list those properties. So acids, let's go, oh, whoa, sorry about that. Laptop's being a bit fiddly today. So let's go, let's go acids, and we can go underneath that, we can go properties. So I'll put it out to the classroom. Can anyone remember any properties of acids? I wonder if anyone can remember any. What properties can we remember of acids? I'll just give you guys a second just to contribute on the chat. I know there's about a 60-second delay. Sorry about that. Corrosive. I like it. Sour. Callisto, well done. Good job. So I'll put both of those down. Number 1, sour. Yeah, sour tasting. Sour tasting. Now, we don't tend to taste things in chemistry. Yeah, there you go. Well done, Zina. Sour taste as well. Now, can I just point out, I'm not overly, you do not really need this one for GCSE, but it's nice. No, Zina, flip it, please. Yeah, this one's really not needed for GCSE anymore. This GCSE, not really. It's just we don't taste things in chemistry, so this one kind of dies a death at this point, but we teach it in year 7 because you taste them in foods. Bases are bitter. That's correct, Ian. Well done. Well done, Gayatri, for giving me the correct pH range. I like it. So we've got Masaru now comes up with the first one. So acids, and this is important, are corrosive. And we pick up a safety symbol. They're corrosive. And here's your safety symbol for this, which is you have like a bar of metal with a little notch taken out of it. I'm going to try and do that a bit better. There we go. And then you kind of see them kind of tipping the acid into it. Yeah, corrosive. And then you have a hand. Like that. There we go. So this is the symbol, corrosive. And we picked that one back. Soapy and slippery. That's good. Yeah, that's undersolid. Yeah, fair enough. Cool. So we pick up corrosive. I like it. Can I just point out they're also in terms of state hazard symbols. You don't really come across corrosive until you become quite a high concentration. So there are another property, which is another hazard symbol, which is an irritant, which is much more common for dilute acids. And the irritant symbol is an X with an I. Little I, there we go. So this is corrosive. Now, they often give you these diagrams at GCSE, folks, and ask you to recognize them and name them. So we've got corrosive and irritant. I like it. The next one, which is super important, Gayatri, well done. They have a pH. Now, we pick up pH, yeah, the pH scale in year 7. So we have a pH between 0 to 6. It's actually 0 and below 7. So you could have 6.9. It's easier just to deal with 6, really. But you can have, it's anything below 7. Yeah, it's anything below 7. Since 7's neutral, it's anything below it. So 6.7 is still an acid. It's just a very, very weak one. Now, just to ask a quick question, did anybody in this room ask their teacher what pH stood for and why it had a capital H? Did anybody ask? So pH stands for the potential for hydrogen, and there's my capital letter, hydrogen ions. That's what it stands for. Yeah, well done, Masaru, recognizing the capital H being for hydrogen, and the P stands for potential. Potential of hydrogen ions. Julius, it's not quite enough to say hydrogen. Since hydrogen itself is a gas, we're now talking in acids and bases in terms of what's called H+, which we'll be coming to that soon. So potential for hydrogen ions. Please make that note, please, guys, in your exercise book and make it clear, because this is actually really important. Yeah, we can put that in a little red box and go NB. Nota bene. How much of you guys missed me for that one, right? So this is really important. And it's the H+ ions that's really important. Very important. Yeah, it's H+, not H. I'll just write that there. H+. I like it. So we've got, it's nice that Julius has now given me a nice equation, which is great. He's given me the first of the rules, which is lovely. So does anyone have any other properties of acids apart from being corrosive, having a pH, and sour tasting? And this one's an odd one. Number 3. Acids react with bases. Acids react with bases. Now, this is actually a really odd one because some students often ask me, how do you know if something is an acid or a base? And the answer is you react it with something. You have to actually do a chemical reaction to see if something is acidic or basic. You can use an indicator, but it's reacting with the indicator. It's changing the indicator's color. So it is actually a reaction. So they're reacting with bases. The fourth one is that acids must be in water, to be acidic. Notice the change in word there, switching from acid to acidic. This is the scale, this is the measure. Acidic, acidity, something is an acid and therefore it is acidic, and you measure it on acidity, the scale, like vinegar and baking soda. Yes, so vinegar and baking soda, the vinegar is the acid, the baking soda is the base. So can I ask you guys to also flag this one, please? So an acid is not an acid unless it's in water. So for example, HCl gas, hydrogen chloride, HCl is actually a gas. This is hydrogen chloride. This is hydrogen chloride. Now, and it's a gas. Hydrogen chloride gas, everyone knows, is hydrochloric acid. But a hydrochloric acid can't be called hydrochloric acid if it's a gas. It must be in water. So if I then have HCl aqueous, I would now call that hydrochloric acid. I know it's a really ridiculous situation, that, but unfortunately, Edexcel in the iGCSE picks on this quite a lot. This particular example is Edexcel heavy, Edexcel common. They love this. They will give you that and ask you to name it, and everyone calls it hydrochloric acid and you lose the mark. They give you this one and you can't call it hydrogen chloride anymore. Isn't that a nightmare? So it's something to bear in mind. Yeah, an acid cannot be an acid unless it's in water. Okay? It's really, really important. Okay. Phone's buzzing. Don't know why. Give me a sec. Okay, gonna ignore that. Right. So acids are not acids unless they're in water. Okay, so we've covered the acids. We need colors. This is where we're going into our indicators. So this is property number 5. So do I want to cover it in acids? Yeah, I can do. Acids, do I want to? I'll do it in indicators. No, I'll leave it there. Okay, so we've covered acids. Let's now go to bases. Let's go to bases. Now, the first thing is we need to make the distinction between a base and an alkali. So there are 2 families. So in the acid-base world, we have this image. Here are the family of acids, and everybody sits inside this family. HF, HNO3, H2SO4, vinegar, CH3COOH. Let's go for HI, hydroiodic acid. So all the acids fit inside. Mr. Duncan, Navina said she's having Wi-Fi problems, so she's having trouble joining. Okay, Gayatri, just let Navina know that she can always watch it on YouTube later. That'd be great. So we've got the family of acids. What we now need to do is introduce our family of bases. The true opposite of an acid is a base. Acid and base. I think that's actually the wrong way round. There we go. Acid and base. Now, what's strange about the base family is that there's a second family inside it. So what we have is bases like calcium carbonate, limestone, super important for Edexcel. That's limestone, really important. Calcium carbonate, limestone, not stone. There we go. We've got other ones like, I'm gonna be careful here, like, I'm trying to pick ones which are completely insoluble. It's not actually particularly easy, that. Come on. Basically, any group 2 carbonate ain't soluble. Calcium carbonate. Magnesium oxide isn't soluble. It is, but at tiny, like next to 0. It basically goes there. Basically. Basically. What else? Aluminium hydroxide. That's not soluble. There we go. Metals, magnesium, aluminium metal, Al. Now, so we've got bases, and then we've got this extra little family called alkalis. Now, alkalis, and this is the nota bene, which is really important, are soluble bases. Soluble bases. They dissolve in water. Dissolve in water. Dissolve in water. So, for example, sodium hydroxide, NaOH, all group 1 hydroxides are soluble. So that can be aqueous as well as a solid. So there are 2, it's an odd world, isn't it? And it's a strange thing because not all bases are alkalis, but all alkalis are bases. It's a bit like all jacuzzis are hot tubs, but not all hot tubs are jacuzzis, because jacuzzis is a brand name. Yeah. Yeah. Anyway, so that's a really important picture, guys, for GCSE, that one. I've tried to give you as many of the ones that I know come up as often as possible in that picture. Screenshot that if you like, guys, but that needs to be in your notes. All acids are aqueous. All acids are aqueous, but not all bases can be aqueous. So they would be classed as bases, but not alkalis. All alkalis are bases. So the word base is much better because it's more complete. I don't know why we teach the word alkali. It's madness. I don't. In year 7, I teach acids and bases. Yeah, and I actually add this picture in at Key Stage 3. This is something I do at year 7. I know that not all people do it. Mr. Duncan, I still don't get the difference between a base and an alkali. Okay, so if I had acid plus base, and that base was a solid, yeah, I know that can be a base. You know what? I don't like this. I need real equations. So, Zyna, for example, if I take hydrochloric acid, HCl aqueous, and I react it with aluminium, I am going to get, so this is a metal plus acid reaction, and that's aluminium solid. Yeah, I'm going to get aluminium chloride, aqueous, and hydrogen gas. Balance the equation. Common denominator 2, and then 6, and then 2, and then 3. There we go. I think that all adds up. 6 hydrogens, 6 hydrogens, 6 chlorides, 6 chlorides, 2 aluminiums, 2 all good. Yeah, and then add a gas in there. So, Zyna, you would agree that because this one here is the acid, and in property number 2, nope, property number 3 states an acid will react with a base. So, if this reaction happens, which it does, what that tells us is that the aluminium must be the base. Yeah, this is the base. Yeah, aluminium is a base. Zyna, are you okay with this? So the next thing is aluminium metal soluble? If I take aluminium foil, silver, shiny aluminium foil, and I put it in a beaker of water, is it going to dissolve? The answer is, of course not. Yeah, the foil will just simply float around in it. Yeah, in fact, I can even do a neat trick being on a tablet. Yeah, I can go copy and nope, and le paste. Whee. And I can grab him. Oh no, grab you, bring you over here. What you would absolutely agree with me, Zyna, here is that the aluminium foil is gonna do absolutely nothing. We know this. Yet the foil wouldn't dissolve. It would just sit there in the water. What that means is that aluminium is a base. Yeah, Al, aluminium solid metal, yeah, is a base because it reacted with an acid, but that is a big but. But not an alkali. It's not an alkali. Yeah, because it's not soluble, because it did not dissolve in water. Just floats around, going, why have you put me in water? Zyna, does this now make sense? And by the way, Zyna, thank you. Like, as a teacher of chemistry, chemistry is hard and complicated, and if you don't get it, Zyna, half the class don't get it. I'd like to think that everyone would be saying, Mr. Duncan, I so don't understand what's going on. Can you please explain it better? And I can always make this clearer. Yeah. So it's definitely, aluminium is definitely a base, but it's definitely not an alkali. So it would live in this bit here of the family, but not in the alkali family. Fab. Thank you. Glad you asked. Okay, so we're making great progress. So now that we've ticked off, we can add just a bullet point here, which is bullet point number 1, Alkali. Oh, what is wrong with me today? Alkalis are soluble bases. Yep, soluble bases. They dissolve in water. Next thing. They are bitter in taste. Bitter in taste. Now, we don't need this for GCSE. You're not going to use that one anymore. It's dead, but it's nice to cover it. This one actually from Zyner is really good. They are soapy. Soapy and slippery. And by the way, that one has been on GCSE before. Very interesting. It described this. It described a student in year 7 on a GCSE paper. It described this. Stephen in year 7 is playing around with acids and alkalis. And one of the objects, which was B, has a slippery texture. Was it an acid or a base? It was that stupid. Like, it was really weird. I was just like, really? Really? I always used to tell students that one just doesn't matter. But it came up. Just letting you know. Okay, next thing. They have a pH above 7. So that would be 7.1 up to 14. I like it. So there we go. So these here are alkalis or bases. By the way, you can't measure somebody's pH unless they're in water. Just so you know. It's tricky to measure someone's pH without it being in water. So it's something to consider. You can only actually measure the pH of an alkali and not a base. Tell you that way. Anyway, next. What else do we want for bases? Common bases to know. Oh, I should have added up there in my acids. Acids to learn. Yeah, let's do that. This is a little side note. Sorry, folks. Throw this off on the side. Acids to learn. Put it in a red box. Yeah, acids to learn. HCl, aqueous. Hydrochloric acid. I've done this with you before, guys. You're realizing that everything about chemistry is about repetition and building that knowledge base. Nitric acid, HNO3, aqueous. Nitric acid, the long lost forgotten acid. Oh, poor nitric. H2SO4, aqueous. Sulfuric with an F, sulfuric acid. pH is an ancient English misspelling, so don't spell it with a PH anymore, even though you'll see it on the internet. Ignore it, it's garbage. Next one, this one's an important one. Ethanoic acid, and what a weird formula that is. Ethanoic acid, commonly known as vinegar. Isn't that cool? There we go. These are acids to know. Can I just say, by the way, that today I have my ILL exams, Hi, Kisaru. IAL exams. Best of luck. Are you AS or A2? I hope you watched all of my all my lessons on my AS ones. I'm sorry that it's not complete yet. Yeah. So ethanoic acid, really useful. Just to add in another one here, guys. This is actually, Kisaru, quite useful for you. Comes up more in AS than GCSE. It does occasionally crop up in GCSE. So one of the things that you guys learn is that sulfur dioxide gas, SO2 gas, is an acidic gas. Acidic gas. Now, the reason why it's an acidic gas is because it reacts with water to form H2SO3. Yeah, I watched all. Well done. Good job. I hope you found them useful. This one here is not sulfuric. Notice the difference. There's a difference here. This one here is sulfuric. Yeah, and it's got a 4 in it. Yeah, it's so important, that 4 there. This is sulfurous acid. Sulfurous, and it's a weak acid. Sulfurous acid. It's another one that comes up regularly at GCSE. Regularly. And very regularly at A-level all the time. Okay, so pH above 7. Anything else I want to add to my bases? I don't think so. But oh, yeah, we may as well add in the rules. So, metals. So, what are bases? What are bases? Question mark. Bases, question mark. They are metals. Number 1, metals. Metals react with acid. Yeah, you add almost any metal. You can even react gold if you've got a strong enough acid. You have to make what's called auric acid. No, got to be careful now. Auric acid is the acid outcome. You've got to use aqua regia, scary stuff. But metals are bases. They will react with acids to form salt and hydrogen. Number 2, metal oxides. Metal oxides are also bases. And number 3 is metal carbonates. Now, what you'll notice there, guys, is essentially anything that has a metal ion in it can act as a base. Now, I shouldn't really say that. Metal sulfates don't. Metal chlorides don't either. But the oxides and carbonates do. I am also going to give you a very important thing in a minute. It's part of GCSE, and I'll add that in a second. I've forgotten one, which is number 4, metal hydroxides. Metal hydroxides. Those are usually grouped hydroxides. These are our bases. So an example would be sodium is a base. Sodium oxide is a base. Sodium carbonate is a base. And sodium hydroxide is a base. They're actually really handy to you to know those. Really, really useful. Any hydroxide, oxide, or carbonate. I always wondered how I could link the first letters to the word base. And I could never really figure out how. Just CHO. Carbonate, hydroxides, oxides. Not that it matters. Oh, I've got MO, MCO3. I shouldn't do that because the formulas will change. Metals, metal oxides, metal carbonates, metal hydroxides. Mocha. Mooch. Mooch works. Anyway, you always mooch on bases. Anyway, so these are bases. This is, by the way, hence why group 1 is called the alkali metals, just so you know. It's nice to pick up those things, guys. Just a reminder of group 1 chemistry. Group 1, the alkali metals. Yeah, the reason why they're called the alkali metals is because when you react any group 1 metal with water, you form the soluble hydroxide and hydrogen balance the equation. Yeah, and this is aqueous. So you're forming a soluble base. A soluble base when it reacts with water. Hence, sir, is H ion acid as well? Yes, Jack, it is. Hydroiodic acid. So if you look at group 7, this is group 7 chemistry. Group 7, you've got fluorine, chlorine, bromine, and iodine. And if you read those elements also, got to be careful here. Got to be careful. Yeah. Anyway, so if you turn each of these, if you react each of these with hydrogen, H2 plus F2, you form HF, hydrofluoric acid. As a gas, it would be hydrogen fluoride, but you dissolve it in water, you add this to water, and you will get hydrofluoric acid. By the way, terrifying stuff. Hydrofluoric acid, terrifying stuff. It actually passes through your skin and dissolves your bones. Really scary stuff. Same thing, if you take H2, hydrogen gas, react it with chlorine gas, you'll get 2 HCl gases, and that's hydrogen chloride. That's hydrogen chloride, and you dissolve that in water, and it will become hydrochloric acid, HCl aqueous is hydrochloric acid. Hydrochloric. And then if you then take bromine and react that with hydrogen, with bromine, you form hydrogen bromide. Hydrogen bromide. Hydrogen bromide. And you dissolve that in water and you get HBr aqueous, which is hydrobromic acid. Hydrobromic acid. If you take H2 and I2 with iodine, then you form HI, which is hydrogen iodide as a gas. All of these are gases, iodide, and that's a gas. You put that into water. They're all soluble, by the way. They just dissolve into the water, extremely soluble. You form HI aqueous, which is hydroiodic. What a lovely name. Iodic acid. Iodic acid. Hydroiodic acid. Really nice, great equations as well. Lovely. Jack, great question. Yes, they are. You could even react it with astatine, but there aren't enough atoms of astatine to really play around with. But you would form hydrogen acetate, and then it would become astatine, iodine, I don't know what it would be. Hydroastiodic, something like that. Hydrobromic. No, astinic. Hydroastinic. Astatide. Don't know. I'll have to look that one up. HAS. Hydroastinic. That's what I'd call it. Hydroastinic acid. Hydroastatic. Isn't that funny? Hydrogen astatide. So is it? Well, isn't that cool? So it would become in water hydroastatic acid. Isn't that clever? Huh. Interesting. Clever. So it does exist, but very rare. As I said, holds the world record for the least number of atoms of that element on the planet. It's kind of cool, that Guinness Book of World Records. Anyway, so we're covering the bases and we're kind of doing some lovely reactions. It's nice to mention group 1 because when they go into water, they form our basic solutions with a pH of 14. And then our group 7, the hydrogen halides, which are all acidic. It's nice that. They all have a pH of 1, by the way. 1. Okay, so we can definitely say that we're kind of halfway through. We've certainly done an awful lot of the recap from Key Stage 3. The Key Stage 3 will also then require in terms of indicators. So our next heading today, guys, is indicators. Indicators. So indicators, a chemical that changes color, in the presence, I can't spell presence. In the presence. Somebody help me. Presence of acid or base. And I'll actually put all alkali because that way it does kind of need to be an alkali because you can't use an indicator with just an insoluble base. So I can use the word alkali there. Yeah. So the indicators you need to know for GCSE. Indicator number 1. Casario has loads of others indicators that he needs to know for A-level, but they'll provide you with a list of the indicators and what range they change at. Presence. Thanks. Thank you, Zina. There we go. Presence of acid or alkali. So number 1 is litmus. So litmus paper, which is commonly what you guys see it as. By the way, litmus is actually a liquid. It's a solution, and it's just been put onto paper. It's been dissolved in water, and they put the paper in it. The paper soaks it up, so it becomes litmus paper. So litmus paper. There are 2 colors of litmus. There is blue litmus. Now, litmus, when it's blue, is alkali, is basic, yeah? And it is red in acid. This one's super common. Everyone knows it, dead easy, but only two colors, yeah? If you were neutral, so water, if you did water with litmus, it just won't change, yeah? That's a little nota bene, yeah? Litmus won't change color, in neutral. Now, litmus is a bit of a pain, and they do this all the time at GCSE, won't change color in neutral. So what they'll do is just an exam style question here. Yeah, student A adds red litmus into beaker A, into beaker 1. So he's got beaker 1, yeah, with an unknown solution, and he uses a piece of red litmus paper. And what it will say is, it will say observations, yep, observations, no change. And they will say, what can you determine from this? Yeah, and the answer is, yeah, so this is no change, conclusion, beaker 1 contains either, this is the important bit, either neutral or acidic solution. Because the reason being is, if it's red, then it would stay red anyway. So they will then say is student B adds blue litmus to beaker 1. Observations, let's draw the picture. So he's still got solution 1. Yeah, one of them added red, the other is using blue litmus paper. Observations, no change. Right, now what can we conclude? Conclusion, solution 1 is neutral. Solution 1 is neutral because neither changed color. What is normally the original color of litmus? Julius, there isn't a normal color. The reason being is litmus is actually changed from red to blue in the presence of a base. So you can set up, there are two, what you teach in year 7 is that there are two types of litmus. You go, there's red litmus and there's blue litmus. That's not true. It's actually just litmus, just depending on what the original condition is. So if you put litmus indicator in acid, by the way, okay, litmus powder is white, just so you know. You add litmus powder to acid and it's red. Yeah, you add litmus powder to an alkali and it's blue. And then you just have to flip it over by adding your substances. So essentially, the paper here is acid. Yeah, this was acid paper. This was acid paper. Yeah, and this was alkali paper. Alkali paper. Yeah, alkali paper. By the way, if you dehydrate them, if you put those litmus papers into a desiccator and you remove all the water, they turn white. They need, for an indicator to be colored, it needs water. So the papers actually dry out of it. That's why it's really, really, really pale red and pale blue. Luckily, there's enough water in the air to maintain it. Litmus paper. You realize it's really, really pale. When you take it home, I want litmus. Yeah, it's really, really pale. And then when you make them wet, they get darker. Yeah, there you go. So if you dry those out, they go completely white. There's a little bit of water from the air that keeps them that little bit blue and a little bit red. But there is only actually one litmus. It's tricky, that. But really, it's about the practical scenarios that tend to be asked in GCSE papers, just so you know. Okay, so we've covered litmus. Indicator number 2. Everyone, let's do the one that everyone struggles with. Methyl orange. Methyl orange. Orange. Right, so methyl orange is another indicator, and it is, methyl orange is red in acid. Nice and easy. Red in acid. This is the tricky one, though. It's yellow in alkali. You have to know this, by the way, folks. You've got to learn it. Sorry. It's yellow in alkali. Just to let you know, at neutral, it's orange. It's tricky, that. Neutral, it's orange. You very rarely see it as orange. But, yeah, anyway. Neutral, it is technically orange. Can I just point out that this is 4 titrations, which we're doing soon in this topic, 4 titrations only. Yeah, you'll understand that. See later notes if you like. Right, next. Number 3, phenol, PHTHLALEIN, phenolphthalein. Now, phenolphthalein is colorless in acid. It's colorless. Colorless in acid. And Barbie pink in alkali. Pink in alkali. Got to know that one too. Neutral, by the way, it's colorless, just so you know. Colorless when neutral. You don't need to worry about that one either in terms of its neutral color. Don't need it. We never talk about it, but it is technically, if you want to, if you do actually add, I can add that. It is colorless and neutral. Colorless in neutral. pH 7. Okay, we're nearly there, folks. There's only 4 indicators for GCSE, just 4. Yeah, and the last one is universal. That's it. Universal indicator. Universal indicator. And this one, of course, has many colors. We all know this. We have red, strong acid. Can I just point out this is all a lie at this point? I'll tell you why later. Orange, yellow, green, dark green, blue, and then purple, dark purple. There we go. Those are your universal indicator colors, just so you know. So these ones are pH down here. This is your low pH. This, of course, is pH 7. Yeah. pH is, that one's 7. This one's 14. This one's 1. Yeah. Orange and yellow tends to be between 4 and 6. This one tends to be between 8 to 11. There you go. So it doesn't really matter that I'm not giving the full range. It doesn't really matter. You stop kind of using the numbers. So they do every now and again come up, but it requires us to see questions more than anything else. Now, can I just make a nota bene at this point? Nota bene. This is again, see later notes. You can't use universal ind for a titration. Yeah, multiple color changes. We'll see that note again, by the way. That nota bene will appear again in our titration lessons, but it's just nice to include it here. By the way, so people often ask me, so what is universal indicator used for? It's used for measuring pH, to give you a rough idea of what the pH would be. Yeah, that's all it's used for. its uses, used to give a rough pH value. It's not accurate. Why would someone use phenolphthalein when it can't distinguish between acid and neutral? Because you're not trying to get to neutral. Masaru, that question is an outstanding question. That's an A-level question. The answer is actually in GCSE, and it's in the titrations lesson. So the reason being, we love phenolphthalein. Of all the indicators that I've given you today, Masaru, this one is our #1 indicator. The reason being is we use it at titration. So this is me doing a little bit on titrations. At titrations, you take a long tube filled with an acid or alkali, filled with, let's just do an acid. And I'm going to add that acid to a base, to an alkali. Yeah, add that to an alkali. Now, what we do is when we add the acid to it, what we want to do is we're using this to find out the concentration of the alkali. This is unknown concentration. Unknown concentration. But this one here is known. So what we can do is we can add the acid really accurately. And what we do is we see this go in alkali. This would be pink. This would be bright pink because it's alkali at the bottom. And then as I add acid, all of a sudden, Masaru, it'll go pink, 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 colorless, and you stop. Because it shows you a distinct, you've gone from alkali, 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 alkali. Stop, you're done. Yeah, it'll drop into being acidic. Even one drop will skip the dead neutral, and it'll become an acid, and it will suddenly go colorless. So it doesn't matter that it's colorless and neutral, because you never really have neutral. It's really tricky to get in reality. I hope that makes sense, Masaru. Anyway, so we've done our indicators. Let's go back to my learning objectives. Right, guys, the lesson is over. So I'm going to end my lesson there today. We will pick up our acid-base reactions next time. Let's go back to here. Let's go camera settings. Go back to my normal camera. Camera front. Hello, I'm back. Right, guys, I will leave you be. Stop share. There we go. I hope you found the lesson useful, guys. As a nice kind of a general summary of Key Stage 3 and lots of the information that we picked up. It's been a long time since you've seen it. Long time. So it's worthwhile kind of going through those. And we picked up 4 indicators, which is really the first step in GCSE. Just getting you guys to recognize that these indicators, you have to know their colors. Okay, guys, I'll see you all next lesson. See you tomorrow, folks.